a bit revision on what we learned on Friday. So on Friday, we have evaluate some values. Okay, I ask you to remember this table, sine, cosine, tangent table, 30, 45, 60 degrees, pound, 6 pound, 4 pound, 3 is the radian form. Remember the first row is root 1, root 2, root 3 over 2. The other row, root 3, root 2, root 1 over 2. And the third row, you just need to figure out the first column is 1 over root 3. And then the next one is 1, and the third one is root 3. So it's very easy to make this table. Every time I ask you, what sine 60 degrees? If you can't remember the value directly, draw the table quickly and then see where is it. Or you can just simply, okay, sine 60 should be first row, the third one, that's a root 3 over 2. That's how most of the students can memorize it. And then after you know 30, 45, 60, those three angles, they are special because their trig ratios are very nice, okay? You can write them down. We also have the second group of special angles. Okay, second group of special angles, they are the angles with reference angle of 30, 45, 60 degrees. So what's the reference angle? Reference angle is when you draw the angle line, and that angle line make the acute angle that the angle line make with the horizontal axis. Okay, you draw the angle line, you have the horizontal axis, there's a small angle formed by those two lines, and that is the reference angle. So how do we evaluate those angles? The first thing is we change the big angle, the actual angle, into our reference angle. As we know, reference angle is angle in between 0 to 90 degrees. Okay, we change the angle first. And then we see, okay, whether this angle is in its own quadrant. Okay, so sine, cosine, tangent, CAST, the cast quadrant. If it is in its own quadrant, say the positive quadrant, then we have positive signs in front. If we have it's in the other quadrant, then we put the negative sign in front of that. Okay, so we use the same idea to prove all the formulas for today. Okay, if you can see example 1 here. Okay, example 1, I want you to evaluate. Okay, if you read them horizontally, I want you to evaluate sine pi minus theta is what? Sine pi plus theta is what? Sine 2 pi minus theta is what? And sine minus theta is what? Okay, I will show you the first one. First of all, I want to say theta in this case. Theta can be any value. Can be 0, can be in between 0 to 90, can be anything. Okay, can be anything. There's no restrictions on theta. But in this situation, I want to assume theta belongs to 0 to pound 2, so 0 to 90 degrees. I want to assume. Why I can assume that? Because it's a true formula for all the angles. Then if I can think about, okay, for this angle, what the formula looks like, then it will look the same for all the rest of the values. Okay, now let's assume theta is an acute angle. 0 to 90 is an acute angle. Can you tell me where is pi minus theta? In which quadrant? Pi minus theta in which one? What's pi? 180 and minus a little bit, a small angle? Second. Okay, let's draw any, Let's draw any angle in the second quadrant. Any angle in the second quadrant, okay? Okay, what I will do, I will draw angle here. Well, it can be, if theta is acute, you can have any angle in between like 90 to 180. So I will say this is pi minus theta. What is the reference angle for this angle? Where is the reference angle, in other words? Here is the reference, right? This is the reference, right? The angle line made with the acute angle made with the horizontal. What the size of this angle here? Theta. Good. The angle is just theta. Okay, when we try to evaluate things, what's the first step to do? Change what? Change the actual angle into reference angle. Okay, so look at the first column. Look at the first column. I want to evaluate sine pi minus theta, cosine pi minus theta, and tangent pi minus theta. So pi minus theta is the same angle. I have sketched it here. So I can change all the actual angle into reference angle. Okay, all the actual angle into reference angle. Whose quadrant is this one? Sine, S. So which one should be positive? Sine will be positive. Then the cosine and tangent, they should add negative sign on it. Okay, so what formulas do we have? We have three formulas in this question. Sine pi minus theta is sine theta. Cosine pi minus theta is minus cosine theta. Tangent pi minus theta is minus tan theta. Okay? That's how we find the, well, theta can be anything. Pi minus theta is not necessary in the second quadrant. It can be in any quadrant. But in this case, I just want to make the question simple. Okay? So, because theta can be anything, this formula is true for anything. I can assume anywhere. Okay? I can assume it's just the angle in between 0 to 90. And then, I just want to, this is not a proper proof. What all I want to do here is find a way to remember the formula. You don't want to remember 12 formulas, okay? So that's how you can do it. Assume theta is in between 0 to 90, sketch it and apply the formula to it. Similarly, let's do the next one. Next one is pi plus theta. Which quadrant pi plus theta should be? Third. Okay, I said this one is pi plus theta. What's the reference angle for this one? Theta, right? Theta. So here, pi over a bit, that's theta. Yeah? So whose quadrant is this one? 10. So actual angle can be changed into reference angle. And only 10 is positive, then sine and cosine will be negative. Sine, cosine will be negative. Alright. Next, 2 pi minus theta and theta. What's the relationship between them? 2 pi minus theta and minus theta. What's the relationship between them? Or anything you can figure out from those two angles? It's the same. Well, I can't say it's the same angle. It's one angle adding to pi. So it will be at the same position. Okay, it will be at the same position. And as I said, if angles at the same position, then they will have all the trig ratio as the same thing. Okay, if the angles at the same position, then they will be the same for all the sine, cosine, tangent values. So where is it? Which quadrant? Fourth. Okay, if I go for this angle here, I can say it is minus theta if I go from this side. Okay, I can say this is minus theta if I go clockwise. I can go for anti-clockwise to say that's 2 pi minus theta as well. Okay, it depends on how I see this angle. If I go for anti-clockwise, not good. If I go for anti-clockwise, then that's 2 pi minus theta, positive. If I go for clockwise, then that's negative theta. Okay, what's the reference angle for this angle? Reference? theta. It's not negative theta. We don't take negative as reference angle. So it's the actual theta will be the reference angle. So reference angle is theta here. Whose quadrant is this one? Cos. Okay, so they all share the same value. So I can change that to sine theta, cos theta, change to reference, tan theta. Then only cos is positive, sine and tan will be negative. Sine and tan will be negative. So sine negative theta is negative sine theta, cos negative theta is positive cos theta, and tan negative theta is negative tan theta. Any questions? Theta can be anything, okay? Again, theta can be anything. Theta can be 2 pi on 7. Theta can be 7 pi on 4. Theta can be anything, but this formula is always true, okay? This formula is always true. For example, if I have, okay, it is true that sine pi minus theta equals to sine theta. So if I have sine pi minus 7 pi on 4, this equals to sine 7 pi on 4. Okay, it is still true. Even though the theta is not an acute angle, it will still be true. Okay, so we treat this as theta. Pi minus theta equals to sine theta. I know that's a special angle, you can evaluate that, but I just want to show you the formula is still true. Alright, without looking at this table, okay, this table is not something for you to memorize. I'm not going to ask you to memorize this. It's the method you trying to figure out this table is important. So let's not look up to the formula. Let's have a think about what sine pi minus x should be. Well, x is theta as well. It's the same thing. So trying to figure out that quickly. What I will do is, okay, pi minus x, I can assume x is, well, I know in this case, I don't know what in this case x should be, but I just assume it's an acute angle. Therefore, it will be in this quadrant. That's pi minus x. Then x is the reference angle. It is the sine quadrant. So what we have is sine x. That's how quick we can figure that out. And sine x is what? Sine x is given, which is 0.6. So I have 0.6 here. Yeah, so I have 0.6 here. What's sine pi plus x? In the third quadrant, reference angle is x, but it's the tangent quadrant, so it's negative sine x. So we have negative 0.6. Because sine x is given, that's 0.6. Okay, so it's negative 0.6. Okay, next one. 2 pi minus x, which will be here. X is the reference angle, and that's the cosine quadrant. That's negative sine x again. And that's negative 0.6. You sub the value in the end. Okay, after you figure out the formula, then sub the values. Sine minus x is minus sine x. Cos minus x is positive cos x. Okay, that's minus 0.6 again. As I said, the questions are super easy if you can work out the formula. Okay, when you work out the formula, sub values in, question can be super easy. Yes? Okay, any questions from this page? If not, we'll move on to some complex ones. Okay, we'll move on to some complex ones. Okay, again in this exercise, theta can be any value. we assume theta belongs to 0 to pi on 2. Okay, again, it's the same. We assume theta is in between 0 to pi on 2. Okay. Draw a right angle triangle here for me. Okay, I said the hypotenuse is C. Right angle triangle, we have A and B. Okay, if I said this angle is theta, what's this angle will be? (90 minus theta). In pi, what I should say? Pi over 2 minus theta. Okay, I want to use this right angle triangle to prove the first two formulas. These two formulas are very important. Very, very, very important. And that's something you need to remember. Or I reason it by using right angle triangle. It's not really only restricted to right angle triangle. It's actually true for all the theta values. But again, I take theta as 0 to 90 degrees. Okay, the cos theta equals to sine pi over 2 minus theta. What this means is the cos of one angle is the sine of the other angle in the right angle triangle. And that does make sense. Let's have a think. What's cosine theta in this case? What's cosine theta in this case? In this right angle triangle? B over C. What's sine pi over 2 minus theta? B over C again. That's why they're equal. Because the sine of that angle is opposite over hypotenuse, and the cosine of the other angle is adjacent, and that adjacent is the opposite of the other one. Can you think about that? The sine of this angle is the same as cosine of the other angle in right angle triangle. That's how I reason myself. Y is true. Okay, Y is true. Okay, think about all the values we have here. We have pi minus theta, pi plus theta, and 2 pi minus theta. It's all involved pi and 2 pi, so the multiple of pi. But in this case, we have pi over 2. Okay, we have pi over 2. So that's 90 degrees. So 90 degrees minus theta of sine will be the cos. Similarly, the cos of 90 minus theta will be sine of theta. Okay, again, same reason. That's A over C, and that's A over C as well. In the right angle triangle, the sine of one angle will be the same as cosine of the other angle. And the relationship between the angles is theta and 90 minus theta. Okay, so sine of theta will be cos of 90 minus that theta. This formula will be useful for transformation questions. Give you something to think about. How y equals to sine x be transformed to y equals to a third cosine x plus pi on 3. Okay, this is my question. How sine x is transformed to that? You need to change one of the sine become cos, or change one of the cos become sine. Okay, you need to make them both become sine or both become cos. So you need to change one of that. How you can change it? You can use those two formulas to change it. For example, the first equation, y equals to sine x, is the same as cos pi on 2 minus theta. Okay, so it's this one will be changed to y equals to cos pi on 2 minus x. Then you are doing 2 cos, how those 2 cos can transfer to each other. You can apply anything you need. It's pure transformation question after that step. Okay, I'm not going to go through this transformation question here. Well, Just another thing, when mark your paper for the previous one, just a transformation question, if you remember that. I just feel most of you forget everything. You forget about the language, how to describe transformation. Some of you, I get the idea, you still know what transformation you should do, but the formal language is important as well. For example, dilation by a factor of what? From x-axis, or in the direction of something, or along something. You need to get the word correct, okay? You need to get the wording correct. You'll see, I'm not going to talk about more on that. You'll see, I have made the change for you on the paper. You need to be careful with the language you use. Okay, everyone, that two formula required you to memorize, okay? How you can memorize it? I introduced right angle triangle for you to memorize, but something you need to remember. This is not something you can purely prove it. That's something required you to memorize. All right, the next two. We have pi over 2 minus theta, right? Become some theta. Now we have a look at what pi over 2 plus theta looks like. Okay, assume pi over 2 plus theta. Theta is an acute angle. Where is pi over 2 plus theta? Which quadrant? Which one? Second. Good. Let's draw a second quadrant value. Okay, next question is, what is the reference angle, like this angle here? Give you a hint. Here is theta, right? Here is theta. What is it? It's not pi minus theta, similar. Trying to figure it out? You can. Pi over 2 minus theta. Okay, 90 degrees minus theta. Pi over 2 minus theta. Okay, look at the second quadrant. That's 90. And that bit is theta. That is pi over 2 minus theta. Okay, which quadrant is this one? Sine quadrant, right? Okay, what we do? Let's have a look at this. I will prove the first one for you. Sine pi over 2 plus theta. That's the angle over 180 degrees already. So we change the actual angle into reference angle. And because it's still the sine quadrant, we have the plus in the front. And what's sine pi over 2 minus theta? Do you remember? We just learned that. Cos theta. That's why sine pi over 2 plus theta is cos theta as well. So sine pi over 2 plus or minus theta is all cos theta. But this can be proved. Okay, if you remember sine pi over 2 minus theta equals to cos theta, this can be proved. Okay, how about the cosine one? So the cosine pi over 2 minus theta will be a negative cos pi over 2 minus theta. We change it to reference angle and it's the sine quadrant. It's not good, we have the negative. And you know cos pi over 2 minus theta, that's a sine theta. So that's why pi over 2 plus theta, cos pi over 2 plus theta is negative sine theta. Okay, it's negative sine theta. Why we have the negative? Because it's not in its own quadrant. Question?
How do you get from sine pi to plus sine pi?
Change the actual angle into reference. The actual angle is pi over 2 plus theta. The reference angle is pi over 2 minus theta. That's why I can change it. Because reference. Look at the green angle. Look at the green angle there. That's the actual angle, right? Pi over 2 is here. Plus theta. That angle is theta. So here will be pi over 2 minus theta. Here is 90. So it's 90 minus this bit is minus theta. So it's pi over 2 minus theta. Change the angle into reference. Reference is pi over 2 minus theta. It's the sine quadrant. So we call it negative. It's only two steps. Change it to reference angle, decide it's positive or negative. And that's it. Any questions? Yes? Question? No?
Wait, what's okay.
It's sine theta. So we learned that in the previous line. Yes?
So it doesn't matter if it's sine pi of 2 plus p over minus p.
Cos theta. Yes. But cos is different. Cos pi of 2 minus theta is positive sine theta. But cos pi of 2 plus theta is minus sine theta. Cos is different. Look at the formula. That's minus sine theta.
Yeah.
Look at the top. Top is positive sine theta. But the bottom is negative sine theta. Okay, so those four formulas are a bit complex. Okay, so require you to really memorize. And will it be asked in exam? Yes. Okay, VCA exam, multiple choice? Yes. Those four formulas appear a lot. Well, the first two appear a lot. The second two not appear that much, but it does appear before. So you need to remember them. Okay, that's something you need to remember. Last one. Last one. Last one called Pythagorean identity. Okay, Pythagorean identity. Okay, what is Pythagorean? Pythagoras, a squared plus b squared equals to c squared, right? That's Pythagoras. What is formula used for? Just let you know, for any theta, if you know sine, cos, or tangent, any of this, you can figure out the other two. If you know sine, you can figure out cos and tan. If you know tan, you can figure out sine and cos. If you know cos, you can figure out sine and tan. Okay, so if you know any sine, cosine, tangent, you can work out the other two. So this formula is the one that help us to work out the rest. Okay, sine squared plus cos squared equals to 1. Why? Let's draw a unit circle first. Okay, here, draw it for you already. Draw any angle, okay, not necessarily in the first quadrant, draw any angle. Let's draw in the third quadrant maybe. Well, if you like, you can draw in other quadrant. Okay, and then what I'll do, I will draw a vertical line here. Okay, this is 90 degrees. Okay, do you remember what x value represents? Sine or cos? Okay, that angle is theta. Okay, that angle is theta. So it represents the cos value. So here is the x value. It is also the cosine theta value. Doesn't matter if it's negative or positive. It's just a value. This value here represents the sine theta. Okay, that's the y value, represent the sine theta. What's the length of this? That was so ugly. Okay, that. What's that? 1. Unit circle, that's 1. Okay, Pythagoras, a squared plus b squared equals to c squared. Cos squared plus sine squared equals to 1 squared. Yes? Cos squared plus sine squared equals to 1 squared. Well, a, b, and c. C is 1. So sine squared plus cos squared equals to 1. That's called a Pythagorean identity. Okay. We have learned 5 formulas here. We have learned 12 formulas of both, so 17 in total. Well, the first 12 is nothing. Okay, we can prove that easily. The next 5 really required you to memorize it a little bit. Okay, you need you to memorize them. Okay. What I'll do next is really, or say, the only important example for this lesson. Okay, it's really important. How you write it is very, very, very important. Let's have a look at the question. As I said, if you know any of sine, cos, or tangent values, you can figure out the other two. So now this question gives you cos values. cos equals to negative 0.4. Well, I want to make it into a fraction. I don't like decimals in circular functions. I will make it negative 5 over 2 because it involves a lot of square. You don't want the decimal to be square. That's really ugly numbers after you've squared it. Negative 2 over 5.4, okay? Theta is given. Pi is in between pi to 3 pi over 2. Where is that angle? Quadrant 3, right? So this angle is somewhere here in quadrant 3. Whose quadrant is that? 10. Okay, that's the information I know. That's the tangent quadrant. Find the exact value of the following. Okay, Pythagorean identity is used for figure out the other two trig ratios when you have sine or when you have cos. When you have sine, you can work out cos. When you have cos, you can work out sine. So sine equals to what? What do you know is sine squared theta. Well, again, sine squared you can write in this way. But to make it look beautiful, we write the square in the middle. It's actually the reason I feel. Like it just looks better. You don't write the square outside, you write the square in between the angle and the sine. So that's a square. It's sine theta and then squared. Okay, to make it look better. Okay, sine squared theta plus cos squared theta equals to 1. So what do I have? It's cos theta I know. Okay, sub that in. That's negative 2 on 5 squared. That equals to 1. So only thing I'm left with is sine x. Okay, sine theta. So sine, well, I can write in this way for you if that looks better for you. Sine theta squared plus 4 on 25 equals to 1. Okay, 4 on 25, that equals to 1. So what sine theta squared equals to? 1 minus that, so it's 21 over 25. Okay, next thing. What sine theta equals to? That's the question I think is really important. What sine theta equals to? Okay, x squared equals to 4. What x equals to? Plus minus 2, right? Okay. I know you have restrictions on your domain for theta, but doesn't matter. In this step, okay, you need to give both plus minus. You don't reject values in the middle. You do it in the end. You need to list out any possible values or any calculation values from the equation above. You know the log questions for your test, there are two values. I remember someone directly reject one and said, oh, that doesn't work. So you directly not write the two, 1 or 2, I can't remember. So directly not write that value. You will lose the mark. Because from your previous line, you can work out two values. Then the two values need to be listed there and then reject according to any reasons you have. So in this step to next step, sine theta equals to plus minus root 21 on 25. Okay, so sine theta equals to plus minus root 21 on 5. And then you talk about the reasons. You can't have both values, okay? Can't have both values. So you will say, because theta is in between this and this, so sine theta is less than 0. Because it's in a tangent quadrant, that's why it's less than 0. So sine theta equals to negative root 21 on 5. That's a proper method, okay? That's the proper method. You need to show plus minus, then discuss why you reject. Or if both fine, just leave both, okay? If you want to reject, talk about why you reject. Because the angle is in between that to that, that's why it's negative, and therefore you will take the negative, not the positive. Yes?
Why do you know that negative
Sorry?
at the start,
Yeah.
this quadrant is this angle.
Because the angle is given is pi to 3 pi over 2, that's in the third quadrant. Pi to 3 pi over 2, the domain is given. Theta is in between pi and 3 pi over 2. Yes? Yeah? So it's in the third quadrant, so that's why it's tangent quadrant. Okay, have a think about this question. Give you sine, ask you for cos is the same way to do. Okay, or give cos, ask you for sine, that's the same thing. So you use this formula, Pythagorean identity, is give you cos, ask you for sine, give you sine, ask for cos. And you need the plus minus, okay? This question always involves plus minus. It always involves plus minus. And then involves you reject one and you accept one. Let's have a look at how to work out tan. Give you cos, I have worked out sine, and how to work out tangent. What's the formula for tangent, everyone? Sine over cos. Good. Sine over cos. And that is, sine is minus root 21 over 5. We just figure out. Divide by cos. Cos is negative 2 on 5. And that is root 21 on 2. Okay, flip it, cancel the 5, so that's a root 21 on 2. We don't take the negative. Okay, we don't take the negative. Negative cancel. And that makes sense. Why it makes sense? Tangent is positive. Remember, tangent theta for this angle is positive, so we should have positive values. So we have positive root 21 on 2. Okay, without going back, okay, look at the screen. What's sine pi over 2 minus theta? Remember, trying to remember? Cos theta, good. So this formula will be cos theta, and cos theta is negative 2 on 5. Directly answer that is given in the question. So figure out the formula, sine pi over 2 minus theta, that's cos theta, and that's negative 2 on 5. Okay, what's cos pi over 2 minus theta? Sine theta. And that's negative root 21 on 5. Okay, what's sine pi over 2 plus theta? Cos theta. Okay, I hope you really remember. Do not go back to look at it, okay? Negative 2 on 5. Last one, what's cos pi over 2 plus theta? Negative sine theta. And negative of sine theta is negative root 21 on 5. And that is a positive root 21 on 5. Okay, you can directly use the formula if you remember them. Okay, you don't need to show proofs. Any questions? No? Okay, so if you don't have any questions, the rest of the time you can work on your homework. But again, give you some preparations before tomorrow. We'll do graphs tomorrow. And it's super hard. I think that's the most difficult part for circular functions, for sketching. That's what we'll do for tomorrow. Before that, everyone, what I want you to do is revise fully on what we learned so far. You must remember how to evaluate all the two types of special angle, all the angles on the axis, how to evaluate them, and also you need to remember the table, okay? What's the sine, cosine, tangent values for 30, 45, and 60. And any formulas we taught today, remember them. So tomorrow we will do sketching. Okay, you can see a lot of sketching here.